In this video, I'm going to be talking about the average rate of change, which more simply is just the slope of a secant line. And then I'll also show an example where we can write the equation of a secant line. But what is a secant line? Let's start there. So a secant line is just defined as a straight line that touches or joins or intersects a function at 2 points. So if my function is this blue line, then I can draw a straight line that intersects it at 2 points, and that drawing or line is known as a secant line. I can find the slope of this secant line, and that is where we get a little fancy. If I find the slope of the secant line between these 2 points, that is also known as the average slope of this blue function in between those 2 points. So what does that mean? Well, this function, this blue line, the slope is increasing, but it's increasing a bit more here than it is over here. Here it's steeper and it starts to flatten out over here. But the average change there, the average slope, could be defined or described as the slope of this red line or secant line. So if I find the slope between these 2 points, that's the average slope of this function. And slope is also known as a rate of change. It's how much is this function changing. It's increasing, but it's increasing by how much? So every point is increasing a little bit less as I move across this function. But the average rate of change is what's described by finding the slope between these 2 points. We know how to find the slope between 2 points. That goes all the way back to algebra. We know our slope equation, y2 minus y1 over x2 minus x1, which is describing the change in our y values over the change in our x values, or the change in our height over the horizontal change, or vertical change over horizontal change. In pre-calculus, we took that equation and we just made it fancier by using different notation. It didn't change the meaning of it, just the notation used. So y2 became f of b, y1 became f of a, x2 became b, x1 became a. And here's where that came from. If we talk about a similar graph, but instead of using x's and y's, we use function notation, then on the x-axis we have a difference between these 2 points or inputs, a and b. And so the difference or change in our inputs would be b minus a. And so x2 minus x1 just becomes b minus a. Our outputs are described when we plug in an input. So if I plug a into a function, I get my output f of a. If I plug b into that function, I get my output, which is described as f of b. And the difference between those outputs is the change in our outputs, or the change in y values. But in function notation, we describe it as f of b minus f of a. So now we got our slope formula in function notation. Not a different meaning, just a different way of looking at it. We can use that to find the average rate of change of a function. So that's just a fancy way of asking, what is the average slope between 2 points? We're given our interval in this example. We want to find the average rate of change between 0 and 1. Since I'm giving my inputs here, or x values, I can plug them into my function and get my outputs. And then I can use my function notation for slope formula, and we can find that average slope. So I got to evaluate my function when I plug the b value in. And when you're given an interval, it's just alphabetical. A is the left endpoint and b is the right endpoint. So I'm plugging the b value in, or 1, into my function. 1 squared minus 2 times 1 minus 1 gives me negative 2. 1 minus 2 is negative 1, minus 1 is negative 2. Then I want to plug in my a value and evaluate my function. So if I plug 0 in, that's going to cancel the first 2 terms, and I'm going to be left with negative 1. So f of b minus f of a becomes f of 1 minus f of 0, and that would becomes negative 2 minus negative 1, which is just negative 2 plus 1, or negative 1. On the bottom, I'm just substituting my a and b values. So the b value first, so 1 minus 0 just gives me 1. Simplify if necessary. So the average slope becomes -1. And we can look at that graph. I have a negative rate of change, or a negative slope. That means that my function should be decreasing. And this is just the average rate of change. So let's look at that function graph. In between 0 and 1, I can see that my function is in fact decreasing. It's decreasing a lot more over here than it is over here, but on average, I am decreasing by -1. So there's average value of a function, just using that average slope formula. If I can find the slope, and I know some coordinates on my graph, I can actually write the equation of a secant line. So if I'm given a function, and I'm given 2 points on that function, and I join them with a straight line, then I have a secant line. So we're going to find the equation of the secant line on this function at these 2 points. To write the equation of any line, a straight line, we need a slope and we need a point. Well, we can figure out the slope and then we can just choose one of these points. I'm going to use the function notation, or you could even go back to that original slope formula. Since we have the 2 coordinates, we have our y's and x values, and just plug them in to find the slope. y2 minus y1. y2 is -1/6, y1 is 1/2. Now you can find those by plugging in these inputs. That's how we got the y values. So in case you're just given the inputs, plug them in to get those outputs, and then you got your 2 coordinates. On the bottom, we're doing x2 minus x1, so -6 minus 2. And just evaluate it. Doing fraction math, you need common denominators. So -1/2 becomes -3/6. -1/6 minus 3/6 is -4/6. On the bottom, -6 minus 2 is -8. To divide numbers, we multiply by reciprocals. So -4/6 times -1/8 gives us either +4/48, which reduces to 1/12, or maybe you can visualize the cross reducing here. 4 is going to cancel to 1, and 8 is going to cancel to 2, so we got 1/12. So that's our average slope between those 2 points, 1/12. It's increasing, it's a positive slope. We got to choose a point. That's the next thing we need. We need a slope and a point. You can choose any of these 2 points, or any point on the line, really. I chose the first pair because it just seemed easier to work with. And we're going to use point-slope form. Point-slope form allows us to substitute a slope and a point to write the equation of the line. We're going to substitute our point into the x1, y1, and our slope into the m spot. And we're going to leave y and x as variables. They're going to represent any input and give us any output. So y1 is 1/2, but y minus 1/2.
Came to speak to you.
So plugging in y1 and x1 and the slope. Just be careful, you're plugging it directly in here. It's not changing the subtraction unless you're substituting a negative number, in which case you would be subtracting a negative number and it would turn into addition. Just be careful when you're substituting. We'll distribute 1/12 first. So we get 1/12 times x is 1/12 x. 1/12 times -2 is -2/12, which reduces to -1/6. Now we can add that 1/2 to both sides. We're adding fractions, so we'll get a common denominator. 1/2 becomes 3/6. So -1/6 plus 3/6 is 2/6. And our final reducing gives us 1/3. So the equation of that secant line is 1/12 x plus 1/3. Let's take a look at the graph. Remember, the graph of the original function was 1/t, and our secant line should be intersecting at these 2 points. Let's see what happens on the graph. 1/t gives us this red graph here, rational function. And we wanted to intersect it at 2, which gave us an output of 1/2, and -6, which gave us an output of -1/6. And we can see that secant line intersecting those 2 points, and the average slope in between those 2 points turns out to be 1/12. So there you go. Good luck finding average slope